Assalamu alaikum students, I am Asma and I am here with you to present the third program of calculus of BSCS level, which is about the concept of absolute values. But before starting absolute values, I would just briefly explain that what we have studied in our last program. In our last program, we studied real numbers and its classifications, basic operations on real numbers, some intervals, types of intervals, inequalities, and solution of inequalities. Now, by the end of this program, I hope that you would be able to define absolute values, some properties of absolute values, geometric interpretation of absolute values, and triangle inequality. Let's first define that what is absolute value. The effect of taking absolute value of a number is to strip away the minus sign if the number is negative and to leave the number unchanged if it is positive. You can see the definition and elaboration of absolute value on the screen. Absolute value or magnitude of a real number A is denoted by A mod or A absolute, and it is defined by A mod is equal to plus A if A is greater than or equal to 0, which is positive, and A mod is equal to minus A if A is less than 0, which is considered as negative. To explain or to understand the concept of absolute value, you can see some examples on the screen. As in first example, we have mod or modulus 5 is equal to plus 5, as 5 is greater than 0, which is considered as positive integer. As in second example, we have mod minus 4 by 7 or modulus minus 4 by 7, which would be equal to minus time minus 4 by 7, which would result in plus time 4 by 7. As we know that minus 4 by 7 is a negative integer, so modulus or mod minus 4 by 7 would result a positive 4 by 7. Now we come to solve some equations which would be having absolute sign or modulus sign. You can see an example on the screen. The example is to solve x minus 3 modulus is equal to 4. There arises two cases that x minus 3 is equal to minus 4 or x minus 3 is equal to plus 4. Now by solving these equations, we get x is equal to minus 4 plus 3. For the second case, we have x is equal to 4 plus 3. Then by further solving, we would get x is equal to minus 1, or for the second case, we get x is equal to 7. So you can see that the solution set for this equation, which is x minus 3 modulus is equal to 4, the solution set is x is equal to minus 1 or x is equal to 7. You can see another example on the screen where we have to solve modulus 3x minus 2 is equal to modulus 5x plus 4. Here again two cases arises due to this modulus sign, which makes this equation as 3x minus 2 is equal to minus time 5x plus 4 or 3x minus 2 is equal to 5x plus 4. Now by solving these two equations, first we would consider the negative case, which is 3x minus 2 is equal to minus 5x minus 4. Here we have x is equal to minus 1 by 4. Now we would consider the second case. We have 3x minus 2 is equal to 5x plus 4. So by applying this procedure, we would be having minus 2x is equal to 6. Now by dividing minus 2 on both sides of the equation, on the left hand side we would be having x and on the right hand side we would be having minus 3. So the solution set or the solution for this modulus equation would become x is equal to minus 1 by 4 and x is equal to minus 3. Now we will define the relationship which exists between a square root and absolute value. But before explaining this relationship, we would first define that what is a square root. You can see the definition of a square root and the relationship between absolute value and a square root on the screen. The number whose square is a is called a square root of a. So the relationship between square root and absolute value can be defined as under root a square is equal to a modulus. For an example, we would consider if a square under root is equal to under root 9, then this 9 would be considered as a square. Here, by taking under root on both sides or applying under root on both sides, on left hand side we would be having a, and on right hand side we would be having plus minus 3. Now this a would become 3 modulus because we consider 3 modulus as positive 3 and negative 3 as well. So for this case, if a is equal to modulus 3, a would be considered as 3 or a would be considered as minus 3. So in the result we get the same relationship, which is under root a square is equal to modulus a. Now to prove of this identity, we can say the two numbers which are plus a and minus a are the square root of a. Then if a is greater than 0, then plus a is considered as the positive square root of a square, and if a is less than 0, then minus a is considered as positive square root of a square. You can see the explanation of this statement on the screen. Since a square is equal to plus time a square and is equal to minus time a square, because plus a square and minus a square would give you the same number, which is a square. Here we can consider that under root a square is equal to plus a for every positive number, and under root a square is considered as minus a for every negative number. So again we get the same relationship, which is under root a square is equal to a modulus, where a modulus is plus a for every positive number and minus a for every negative number. Now we will explain some properties or some desirable properties of absolute values. You can see 4 properties of absolute values on the screen. Minus a modulus is equal to a. It would state that a number and its negative has same sign. Then as the second property we have a b modulus is equal to a modulus and b modulus, which would state that the absolute value of a product is the product of absolute values. Then as the third property we have a divided by b modulus is equal to a modulus divided by b modulus. Then as the third property we have a divided by b modulus is equal to a modulus divided by b modulus, which would state that the absolute value of a ratio is the ratio of absolute values. And the last property is a raised to the power n modulus is equal to a modulus n time. To prove fourth property, we have a raised to the power n modulus is equal to a modulus raised to the power n. To explain this property, we would start from left hand side, which is a raised to the power n modulus. Now a raised to the power n means a would be multiplied with a n times, which results in a multiplied by a up to son a, where a is considered n times. Now here we would use the second property of absolute values, which is the absolute value of a product is the product of absolute values. So now this equation can be written as a modulus into a modulus into a modulus up to son a modulus, which would be considered as n times. So when bases are same, the powers can be added. So on left hand side we have a raised to the power n modulus is equal to a modulus n times. So in the result we would be having a raised to the power n modulus is equal to a modulus raised to the power n, which is the result of adding the power of all these bases, which are A mod. Now we move to the geometric interpretation of absolute values. The notation of absolute value or modulus naturally arises in distance problems. Now the geometric interpretation of absolute value with the help of distance we can see on the screen. The distance between capital A and capital B having small coordinates A and B would be considered as B minus A if A is less than B, and distance is equal to A minus B if A is greater than B, and distance is equal to 0 if A is equal to B. As a geometric picture of all these three cases, for the first case, which is D is equal to B minus A, we would be having two numbers which are A and B on the real line. Now when A is less than B, so the distance between A and B would become B minus A. For the second case, which is D is equal to A minus B, here again two numbers are B and A, where B is a smaller number than A. So the distance would become A minus B. And then for the third case, which is D is equal to 0, we would consider both of the points which are A and B equal and on the same place on a real line. So the distance between A and B when A is equal to B would result into 0. Generally, we will be using the formula D is equal to B minus A for distance. It provides a useful geometric interpretation of some common mathematical expressions. Now, from the table on the screen, we would explain the geometric interpretation of some mathematical expressions. Now, as the first expression, we have x minus a modulus or distance x minus a. Its geometric interpretation in the real line can be explained as that x minus a modulus is the distance between two numbers which are x and a. The second expression is x plus a modulus or x plus a with a distance sign. The geometric interpretation of this expression can be defined as that it is the distance between two numbers which are x and minus a. The third expression is x modulus. The geometric interpretation of this expression or real line can be stated as that it is the distance between x and origin, where origin is considered as 0. Now there can be two types of inequalities, and the inequalities of the form where x minus a modulus is less than k and x minus a modulus is greater than k arises often. Now we have summarized the key facts in the table which is shown on the screen regarding these two inequalities. As the first inequality, we have x minus a modulus less than k. The geometric interpretation of this inequality can be stated as that x is within k unit of a. The alternate form for this inequality can be written as x minus a is greater than minus k and x minus a is less than k. The solution set for this inequality would be a minus k or a plus k. This solution set can be shown in this figure where you can see 4 points on this line: a minus k, a, x and a plus k. We have explained its geometric interpretation that x is k unit away from a. Now for the second inequality, we have x minus a modulus is greater than k. The geometric interpretation for this inequality is that x is more than k unit away from a. The alternate form of this inequality can be written as x minus a is less than minus k or x minus a is greater than k. The solution set for this inequality would become minus infinity to a minus k union a plus k to plus infinity. Now we will use some inequalities having absolute numbers, which would be explaining the procedure that how we can solve the inequalities which are having absolute signs or absolute values. The procedure for solving the inequalities having absolute numbers is as same as the solution of the equations. The example is that we have to solve 1 divided by modulus 2x minus 3 greater than 5. Here by cross multiplication we would have 2x minus 3 less than 1 by 5. There arises two cases where 2x minus 3 is greater than minus 1 by 5 and 2x minus 3 is less than 1 by 5. By solving these two cases, for the first case we have 2x minus 3 is greater than minus 1 by 5. We would result in x is greater than 7 by 5. Considering the second case, we have 2x minus 3 is less than 1 by 5. We have x is less than 8 divided by 5. So the final solution set for the above equation become x is greater than 7 by 5 or x is less than 8 by 5. Means x would lie between 7 by 5 to 8 by 5. You can see this solution set on a real line that all the numbers between 7 by 5 to 8 by 5 would be included in the solution set, and all the numbers which are less than 7 by 5 and greater than 8 by 5 would not be included in the solution set. Here we move to the last topic of today's lecture, which is triangle inequality. Triangle inequality is a plus b modulus is less than or equal to a modulus plus b modulus. Dear student, that was all for today's program. Let me briefly explain that what we have studied today. We have studied absolute values, properties and examples of absolute values, geometrical interpretation of absolute values with the help of distance, solution of equation involving absolute values, solution of inequality involving absolute values, then converting inequality into intervals, and triangle inequality and the proof of the final theorem. Dear student, I hope that you have enjoyed today's program, and now the concept of absolute numbers and triangle inequality is clear to you all. I hope that you all are now able to define and solve absolute values in equations and inequalities as well. Hopefully, I will meet you in the next program with the concept of coordinate planes and graphs. Till that time, Allah Hafiz.